asks us to draw the two chair conformations for this particular cyclohexane structure. The first thing we should do is number the carbons. I've numbered them here. A couple things to note: it doesn't really matter where you number carbon number 1, and it doesn't really matter if you go clockwise or counterclockwise. You don't even really have to follow IUPAC rules, not for this exercise at least. The next thing we want to do is draw our chair structures. I'll go ahead and draw both of them now, and then we'll figure out how to translate the groups over. Now that I have the two chair structures drawn, I can number these carbons to match the carbons over here. Again, it doesn't really matter where you start with carbon number 1. I'll put carbon number 1 here. Now that I've made this choice, though, I have no more choices for the rest of the structure. I have to number the rest of the molecule according to how I numbered the first one. The choices here were arbitrary. Where I put carbon 1 was arbitrary. From here on out, everything is very purposeful. This structure was numbered clockwise, and so this one also needs to be numbered clockwise. When I number the carbons on the other chair structure, again, I have no choices anymore. In this structure, carbon 1 and carbon 4 are what I call the corner carbons, and they need to stay the corner carbons in my new chair structure. Carbon number 1 rotates up, carbon number 4 rotates down, but they're still the corner carbons of this chair structure. That means this is still carbon number 1, and this is still carbon number 4. The molecule still needs to be numbered clockwise to keep the orientation of the structure the same. Makes this carbon 5 and this carbon 6. Now that I have the structure numbered, now I can translate the substituents over to my new chair structures. On carbon number 6, on a wedge, I have an isopropyl group. The wedge here means nothing about whether it's on an equatorial or axial bond in the chair structure. All it means is that it's sticking up into the northern hemisphere of the molecule. Looking over at carbon 6 is a carbon that's pointed up. That means the axial bond is also pointed up on carbon number 6. And since the isopropyl group was an up group, the isopropyl group on carbon 6 will be in the up position that happens to be an axial position in this molecule. The implied hydrogen is on a dash, and so we'll go ahead and draw that in. That will help us ensure that we draw the correct cis-trans stereochemistry. On carbon 5, I have a methyl group. The methyl group is on a dash. The dash group is sticking down away from me into the southern hemisphere of the molecule. Looking at carbon 5, it's a bond pointed down. So pointed down is the axial position. Pointed down is the group that's in the southern hemisphere. So the methyl group on carbon 5 happens to be in the axial position, not because it's on a wedge or a dash, but because it's in the southern hemisphere in my original structure, and the southern hemisphere bond on carbon 5 happens to be the axial bond. The implied hydrogen on carbon 5 is in the northern hemisphere, and so I can draw that in as the equatorial bond on carbon number 5 as well. This illustrates the trans stereochemistry of the methyl and isopropyl group in this chair structure. I can do the same thing on the new chair structure, the chair flip, in order to conserve the relative stereochemistry. Carbon number 6, the isopropyl group is up into the northern hemisphere. Looking at carbon 6, it's a carbon angled down. That means the axial group is the down group, and the up group is the equatorial group. So the isopropyl group happens to be on an equatorial position on this carbon number 6, not because of anything to do with wedge or dash, but because the wedge group is in the northern hemisphere, and the northern hemisphere bond on carbon 6 here happens to be the equatorial group. The hydrogen on a dash, then, is going to be the southern hemisphere group, and on carbon number 6 in this chair structure, that happens to be the axial position. The methyl group on carbon number 5 is in the southern hemisphere. The southern hemisphere bond here on carbon number 5, this is a carbon pointed up, so the axial bond is pointed up, the equatorial bond is pointed down into the southern hemisphere, and so the CH3 group happens to be in an equatorial position, not because of the dash, but because that's what the southern hemisphere group is on this carbon number 5. Again, we can add in the hydrogen here just to make sure we are clearly showing the cis-trans stereochemistry. This shows that the isopropyl and the methyl group are both trans to each other. And so these are the two chair flips for this particular cyclohexane ring.